Okay, so we're going to use Excel to plot this question. So the enzyme invertase catalyzes the hydrolysis of sucrose into glucose and fructose. So it creates two products. So this table below is the result of different values of sucrose combined with the enzyme invertase. So we have our sucrose concentrations on the left-hand side, which is our substrate, and then we have, over time, the amount of product formed, and specifically the students here were measuring the concentration of glucose. So they weren't looking at fructose, so you can leave fructose out of the problem. So what we're looking for is the initial velocity for each concentration over time. So for our very first value, the initial velocity is by definition, the amount of substrate produced in millimolar divided by the time. So for our first one, we have 0.1 millimolars of glucose produced in 1 minute. So calculating the initial velocity, we'd have 0.1 divided by 1 minute, which would be 0.1. If we keep going down this chart, we'll notice 0.2 divided by 2, and so on. All of these values equal 0.1. So our initial velocity for the substrate concentration of 0.5 millimolars is going to be 0.1. Now, as we work our way down, we'll notice 2.0 millimolars, it stays roughly similar in values. So these are the calculated values of the different substrate concentration, or of the different varyings of time for glucose produced. So what we have here, we have 0.6 millimolars of glucose produced in 1 minute. So that's 0.6, the value here. And then we have 1.1 millimolars of glucose produced in 2 minutes, which is the value here, and so on. So these are all the different values of this chart. So these are the initial velocities. So you'll notice that these initial velocities have varying values, unlike the first one where they're all 0.1. So what we do in a situation like this is they're all relatively close values to each other. So we're going to take the average to find our initial velocity. So if we do that, we'd get an average of 0.55. So you'd add all of these up and divide them by the total number. So then after that, if we continue to increase the concentration of substrate, we're going to start to notice over time the amount of product produced will decrease. So if we look at 20 millimolars right here, we'll notice for the first one, 2.2 millimolars was produced in 1 minute, so that's initial velocity of 2.2. And then if we keep going down, 4.3 in 2 minutes, we have 2.15, 11.2 in 5 minutes, we'll get 2.24. But if we go all the way down to 40 minutes, we'll see that we produce 64.2 millimolars in 40 minutes, and we get a value of 1.6. 1.6 is really radically different from the other numbers. It's off by a total 1 millimolar. It's almost. So this value is radically different from the other ones. For our initial velocity, we want it to remain as a linear curve. So we want it to not have a linear fit, so it shouldn't have a curve on it. So this 1.6 value on a graph would mess up our curve that we produce. So we're going to leave it out of the average. So we take the 5 closest values for this situation. Now if we look down at even more increased concentrations, like 100 millimolars, and we look at the initial velocities produced for each time, we'll notice that the last 2 numbers are radically different from the first 4. So this time, we're only going to average the first 4 numbers. So basically what you want to do when calculating initial velocity is you find the initial velocity for each one, for each time scale, and then you take the closest ones and you find the average. So in this case, only 4 of them were close to each other. There might be a case where only 3 are. So depending on what numbers you have and how close they are, that's what you use to determine your average for your initial velocity.